Welcome back. In the previous video, we talked about the RTDS as a simulated example to build up cyber-physical testbed for studying cybersecurity in smart grids. In this video, we will look at Modelica, a modeling language also for that purpose. We have already looked into Modelica with Peter in week 1. To remind you, Modelica modeling language allows users to perform multi-domain and hybrid modeling. This is quite important because we have mentioned that the power system today is a pure cyber-physical system. And so we have to consider the hybrid modeling to account for its different parts. Modelica also allows users to program their simulations in a visual, acoustical, and hierarchical manner. It's a great tool for analyzing a complex cyber-physical system. Both commercial and open source tools are available. And the open source tool that we will use in this course is Open Modelica. So, with Open Modelica, we can study the cyber-physical power system, even when it comes to cybersecurity. We can model the cyber parts, such as the controls, ICT networks, ICT infrastructures, as well as the physical parts like generators, loads, transmission lines, and so on. The library OpenIPSL provides the power system component models for the power system dynamics simulation. We can use Open Modelica, for example, to model and study the secondary frequency control loop, the so-called automatic generation control, where the frequency and the timelines power flows can be measured by the sensors and transmitted through the SCADA communication network for some control actions to maintain the frequency to its nominal value. We can also build up the control model and different attack models for different types of attacks, such as false data injection attacks, denial of service attacks, and so on, all with Modelica modeling language. Libraries for discrete event-based communication network can also be used for the cyber part modeling. We will have some assignments to get a chance to work with such models. The capability of Modelica in modeling complex cyber-physical power systems and the different types of attacks allows us to evaluate the attack impact by numerical simulations in such a complex scenario. This brings us to the end of this video and to the end of this lecture week. In this set of videos, we have introduced the smart grid cybersecurity risk assessment process. And mainly we focused on two concepts, the vulnerability and the impact. For the vulnerability assessment, we introduced the security index approach for the power system in steady state. Then, we introduced the security index computation, which basically is the index to show how many measurements the attacker has to collect in order to keep it stealthy. We looked at some examples as well. After the analytical methods for vulnerability assessment, we explained how we can study the attack impact through modeling and simulations, which is needed, as our grids and the attacks are too complex for simple analytical methods. We have discussed simulation tools such as RTDS with a strong capability of real-time simulation and interfacing with other devices or software for a cyber-physical test bed. We also discussed the Modelica modeling language with emphasis on its support for hybrid modeling. The current research, in fact, also goes into co-simulations, where different simulators for hybrid models are coordinated globally for a coupled cyber-physical system to see the impact of the attacks and the vulnerability of our hybrid cyber-physical system to these attacks. This lecture was a simple introduction to the topic of cybersecurity in smart grids. If you are interested in more information, more literature will be available on the course page. Thank you for watching.